application developers, if we can take away some of the complexity, some of the decisions they have to make as a developer, right? Like,
What do you mean by complexity? You mean like scaling issues?
Well, yeah, exactly it, right? So I have how much data is there, where are the machines, what machines, how are they interconnected, how do I communicate with them, right? So in one sense with Hadoop, right, we can take and say, the only real question, if you use the MapReduce model or some of the variants, is the question is, what's the data and what's it look like? It's not where's the data, where's the CPU I use? So in Hadoop or an Hbase space, right, it's the same, right? Except you have a different kind of interaction with the software.
There is the thing about the schema.
Okay.
Because all access is via the primary key, and at the moment we don't really have secondary indices or transactions, so people are working on that. The schema has to be designed up front. You have to do some work up front.
But isn't that the same as in like things like MySQL, right? I mean,
true. But I think generally DBAs, they start off with the notion that this is how the schema is going to be today, but they're going to evolve it in a certain direction over time as the access patterns change. Now you can do some of that with Hbase. You can add and remove column families.
But in your time is life of the application versus there's developer time, and you debate with your DBA and you're refactoring. But then there's data lists. This is big data. It lists forever. It's always changing, right? It's never going to be right. You don't, so you've never seen a data warehouse that you didn't have to change a schema for. I mean, you got tons of data in there. So does Hbase alleviate that a little bit because of you're not trying to fully normalize everything and do all this stuff. Because you're limited.
There's a point there. So, yeah. I mean, we plug in well with things like Hadoop. So
right.
So for you can transform or realize views in different tables. All that it's all amenable to that. And it's simple from the get-go. I mean, the schema is not going to be complex in the first place. So.
So you're not going to sit there and try to outsmart yourself coming up with the perfect schema, right? You're gonna do what needs to be done. And a question. So there's limitations in Hbase, correct? Right. So there's things you just can't do. Like I assume you can't do a join. It doesn't really fit the model.
Columns don't have types even.
Right. Right. Well, okay, fair enough.
It's just binary data.
And I've read that but there's versioning. So the benefit here is now I can have a record with versions and time, right? And I can always go back and look at things and do comparisons. So if I'm stuffing pages in Hbase, I didn't look at that page after every fetch for the last 5 years if I had started 5 years ago. And I didn't have to re-architect everything, bidding a new hardware, because all of a sudden, since it's been 5 years, it's 5 times bigger than it was the previous.
Or in year 5 you decide that maybe you're not so much interested in this particular aspect of the page content, but in you have maybe a new analysis tool. Well, you just add a new column family to that same row, bring it up, and then you do your processing, your bulk processing, and add this new attribute on the end of your.
So you can accommodate change over time.
Yeah, but I think what's troubling me here is that a lot of people have already written most of their analytics are in and around SQL, right? And so what's the overhead for them to go ahead and change all this?
Yeah.
And what language do they use? What did they use to query the system with?
You can't hook up Crystal reports to Hbase and have it just work. There's no JDBC driver. I don't think it would ever make any sense to have a JDBC driver for Hbase. It's a problem. I mean, could you run Crystal reports against a repository that has petabytes in it? Maybe people do, but maybe you'd want to start moving. You want to do your analysis using things like MapReduce.
Well, you can always extract subsets, right, and then put it in a relational database to keep it as a
put
cache,
it into a new table,
right? Or another table.
Yeah, so I mean,
so
you
tables
could
on tables.
Yeah.
I see. Okay.
You could run some sort of analysis and then actually extract the data and put it into a form that you'd be able to run SQL.
Yeah, or RDBMS. But a bit smaller.
So the analysis would be out of band. So the traditional models, right?
Yeah.
You run the analysis in SQL in the database, and everybody's inside of it competing with each other. But in the Hbase world, the data's there. You're limited to the kind of transaction.
It's big.
It's big. And you stuff things into it and pull things out. But if you want to do the analysis, you do it out of band. You go and you fetch. You do the analysis. Do some more random fetches, and that's what Hadoop comes into play, right? You build MapReduce and its variant applications.
The product might get put back into.
And then the results can be put back in there or into a relational database. So you would be populating every night.
And then run your crystal reports on some small subset.
And so that makes a lot of sense. That gets you away from this really big file where you have to always constantly scan it. You have random access into the big file. And then we're talking big files, right? But if it's all in Hbase, then you have a primary key. You know how to seek to it, get what you need, do the work. You have history. And then you can go and you can reutilize that in the reporting frameworks that you use. Okay, so they're all complementary. Hadoop, Hbase, and your traditional reporting frameworks. You just create their pipelines and keep it loaded and keep it clean. And but you don't have to focus on these other aspects like where the data is and keeping the machines up, because Hadoop and its replication stuff kind of manages that for you. And very nice. Okay.